So children, coming to Newton's third law. Children, Newton's third law states that. Children, Newton's first law, if you remember, it gave the concept of inertia. Newton's second law, if you see, it gave the concept of momentum. Newton's third law, if you see, it will give law of conservation of momentum. Law of conservation of momentum. Let's check. So Newton's third law states that for every action, there is equal and opposite reaction. This is called Newton's third law. So children, Newton's third law states that for every action there is equal and opposite reaction. Newton's third law, what it states, children? For every action there is equal and opposite reaction. Okay. So if you imagine this is action, okay, reaction will be there. Compulsory reaction will be there, but opposite reaction. For every action there is equal and remember, children, action and reaction after some 2 words. Okay. So see here, children. Some examples. Children. So suppose the famous example, rocket is there. All of you know this one is the famous example. This is rocket. Okay, children. When rocket liberates gases downward, then it starts going up. This is action. This is action, and it is going upward. This is reaction. Okay, one. Suppose there is a boat. Okay, this is the boat. Suddenly, someone jumps into the boat. Okay, action is jumping into the boat. Reaction is boat will move. Action is you are jumping into the boat is action, and reaction is boat is moving a little bit. That is reaction. Suppose recoil of a gun. This is very famous question. Recoil. If you fire a bullet, then gun will go back. When you are firing like this, it will go down. So when you shoot the bullet is action. This is action, and reaction is recoiling of the gun is reaction. Okay, like when you are boating also, children, with the oars you will push the water back. With the oars you will push the water back, and your boat will go front. But with the oars you will push the water back, whereas boat will go front. This is action. This is the reaction. Like that. For every action there is equal and opposite reaction. Okay, children. So I'm showing the law of conservation of momentum. You see here, children. For every action there is equal and opposite reaction. Imagine 2 bodies, M1 and M2. Initial velocity is U1, U2. Okay, they are coming and hitting each other. Okay, after hitting, their velocity changes into V1 and V2. After hitting, they may become common velocity, or their velocities may change, or anything can happen. So children, for every action, force. This is force for action, and there is the opposite action. Children, from Newton's second law, what is the formula for force, children? What is the formula for force we have? mv minus u by t. Okay. This is for the first body we take. m1, v1, u1. And this is for the second body we take. m2, v2 minus u2 by t. Cancels. Time gets cancelled. Because at the same time they are coming in between each other. And children, remember here minus is there, please put minus. This minus there. Okay, children. So now see here, m1 v1 minus m1 u1 is equal to, what is this? Minus m2 v2 minus of minus plus m2 u2. Okay, children. Bring all u's onto one side and v's onto the other. Bring u here, v here. So m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. So this is the law of conservation of momentum. This is momentum before collision is equal to momentum after collision. Means this momentum is 50, this momentum is 60. After so momentum before collision is 110. After collision also, this may become 40, this may become 70, but total will remain same. 110. This may become 30, this may become 80, but total remains same. That is called law of conservation of momentum. Law of conservation of momentum states that momentum before collision will be equal to momentum after collision. have to remember this formula. Remember that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 u1 plus m2 u2 is equal to m1 v1. Momentum before collision is equal to momentum after collision. Like this. Okay. In this one, children, when we are discussing, we have to discuss about the recoiling of gun derivation also will show once. Of course, we won't use direct formula, but how the question will come? Recoiling of the gun. So like then we will ask the exam. Recoiling of gun. Recoiling of gun. Please see here, children. Children, this is gun. Okay. This is gun. This is bullet. This is bullet. Imagine. Initially, the m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Try to understand. Mass of gun m1. Initial velocity of gun is 0 because it is not moving initial. m2 is mass of bullet. Initial velocity of the bullet also 0 because in the gun still we didn't fire. This is mass of gun. This is velocity of gun. This is mass of bullet. This is velocity of bullet. 0 is equal to mass of gun into velocity of gun plus mass of bullet into velocity of bullet. Okay, so this goes here. Mass of gun into velocity of gun is equal to minus mass of bullet into velocity of bullet. Velocity of recoil of gun, this is velocity of recoil of gun is equal to minus mass of bullet into velocity of bullet by mass of gun. This is the formula for the recoil of gun. This is the formula. Recoil of gun means how much fast gun is going back when you shoot the bullet. No need to use the formula, children. Directly they can do, just I'm showing you. That's all. Initially, they both are at rest. That's why I have taken 0, 0. But when it is fired, with what speed the gun is going back, this is the form. This is going here, this is going here. That's why I have taken minus for 1. Okay, children. So if you do some numericals, then you will understand. Children. So this is the law of this. This we have to practice 3-4 times. Derive law of conservation of momentum means for every action, equal and opposite reaction minus we have to put and to that. Momentum before collision is equal to momentum after collision. Okay, children, we'll do some numericals, and we'll understand clearly. So, we will third lot questions. First question. Children, if you are interested, you can tell or else leave. Children, mass of bullet is 20 grams. Okay. And velocity of bullet is, it is fired with 150 meters per second. From a pistol of a gun of mass 2 kg, what is the velocity of recoil of the gun? What is the velocity of recoil of the gun? Now what I told you, again I say, see here. Momentum before collision is equal to momentum after collision. Okay. Mass of bullet initial velocity is 0. Mass of gun initially is at 0. Mass of bullet into velocity of bullet. Mass of gun into velocity of gun. This everything is 0. Anyone say what is the mass of bullet, children? Mass of bullet is how much? Mass of bullet is how much, children? See and tell on the board, children. Someone.
Sir, 20 grams.
20 grams. 20 grams. How to convert it to kgs? By 1000.
By 100.
And velocity of gun only we should find out. Mass of gun is how much, children? Someone says here say 2. And velocity of recoil. Velocity of bullet is how much, children? This is velocity of bullet. I'm sorry. Velocity of bullet is how much, children?
150 meters per second.
Yeah, this way. Thank you. So, children, so 0, 0, 0, 0. 15 2s are 30. 30 by 10 is 3. Plus 2 into velocity of recoil of gun. This goes here. Minus 3 is equal to 2 Vg. This goes down. Vg is equal to minus 3 by 2. That is, with minus 1.5 meter per second, gun will recoil back. Why you got minus, anyone? Why you got minus, anyone?
Retardation.
No, gun is coming back. That's why minus you get. Gun when you're shooting, it will come back. That's why you use minus children. Okay. You have to do like this. This is your textbook question on which one more question. Please keep copying. Don't sit idle. Everyone. Second question. A girl is there, children. The mass of the girl is 40 kg. She jumps with a velocity of 5 meters per second. 5 meters per second into a stationary car. Car means symbolic motion. Car. She is jumping into this car. The mass, I'm sorry, mass of the car is 3 kgs. Okay. So when she jumps, what is the velocity of the car? When she jumps, what is the velocity of the car? Again, law of conservation of momentum. Momentum before collision is equal to momentum after collision. Okay. Mass of girl, velocity of girl, mass of car, initial velocity of car, mass of girl, final velocity of girl, mass of car, final velocity of the car. Yes, children. So, see here, children. So, a girl is 40 kg. She is jumping with 5 meters per second. Mass of car is 3 kg. Initially, car is at rest. Initially. Mass of girl is 40 kg. After jumping, she will come to rest on children 0. After jumping, she will sit there and she won't run it on the cart. Mass of cart is how much, children? 3 kg. We have to find velocity of the cart is how much after she jump. Velocity of cart is how much after she jump. This is 200. This is 3. This 3 goes down. So, how much in this is the 66.67 meter per second cart moves. If she jumps with 5 meters per second, cart will move with this speed. 66.67 meters per second, cart will move. This is the question. Yes, children, anyone have any doubt in this? When she will jump in, children, initially cart is at rest. After jumping, girl will come rest. That's why I have taken 0, 0. You should know all these things, children. If not in the exam, you will not get confusion. How many sums you practice, that much strong you will become. Next question. Yeah, children, next question. And this only. One more question will be. A body of mass 2 kg. A body of mass 2 kg. Third sum 100. A body of mass 2 kg initially moving with 10 meters per second. Initially moving with 10 meters per second. Okay, initially moving with 10 meters per second. Collides with another body of mass 5 kg, which was at rest initially. After collision, velocity of the first body becomes, after collision, this is becoming 1 meter per second. Okay, what will be the velocity of the second body? This is M1, U1, V1. This is M2, U2, V2. Anyone wants to try, children, or should I tell? Momentum before collision, M1, U1 plus M2, U2 is equal to momentum after collision. Momentum before collision is equal to momentum after collision. So first body children 2 into 10. Second body children 5 into 0. First body children 2 into 1. Second body is 5 into B. You have to find the velocity of the second body after the collision. 20 is equal to 2 plus 5B. 18 is equal to 5B. B is equal to 5 3s are 15. 3.6 meters per second will be the velocity of the second body, which was initially at rest. After hitting by this body, even though it is at 0, this has become 3.6 meters per second. You can check, children. Okay, children, next question. Fourth question. Fourth question. Anyone wants to try it? Mass of bullet is 100 grams. Mass of gun is 4 kg. bullet is fired with a velocity of 200 meters per second. What is the velocity of recoil of the gun? What is the velocity of recoil of the gun? Anyone wants to try, children? Sharma, you want to try?
Yes, sir.
Tell me, problem. Momentum
M1 momentum
before collision.
before collision is equals to momentum after collision.
Okay, now let's change it to bullets and guns. All mass of bullet, initial velocity of bullet.
Initial velocity of
Mass of gun.
mass of what's
Mass of bullet.
mass of bullet.
Final velocity of bullet.
Finals.
Mass of gun.
Mass of gun. Final velocity of gun.
Now tell me substitution.
100 into
100 by 1000. Initially,
100 by 1000. 100 by 1000 into 0 plus 200. What's
4 kg to
4 into 0.
Initially, bullet and then are at rest. That's why taking 0. Now again, you tell.
100 by 1000
Velocity
into
of bullet.
Velocity of bullet is 200
Mass
plus mass of 4 into.
So 0 is equal to 3 zeros has gone. So 20 plus 4g. Okay. Minus 4g is equal to 20. Tell me.
Vg is equals to 20 by 4 minus 4 is equals to minus 5.
Velocity of recoil of gun is how much? It recoils with 5 meters per second. Gun will come back at 5 meters per second.
Yes.
Gun will come back at 5 meters per second. Same like this question only. I will tell again, children. Anyone wants to do it? Same like this. Mass of bullet is 20 grams. Velocity of the bullet is 100 meters per second. Mass of gun is 2 kg. And velocity of recoil of 10 watt. Anyone wants to try, children? Yes, who will try? Who is that? Return.
Mass of bullet
Momentum before collision.
equals momentum after collision.
Momentum. Now tell loudly, man. Tell loudly. Momentum after collision. Yeah. Tell.
Into initial velocity of bullet.
Mass of gun. Initial velocity of gun.
Mass of bullet into
final velocity of bullet plus
mass of gun into final velocity of gun.
Very good. Very good. That keeps it.
20 by 1000 into 0 plus 2 by 2 into 0.
Why you took 0 0 here? Because initially
it is at rest.
But bullet and gun are at rest. Now
20 by 1000 into 100.
Okay.
Plus 2 into V.
This one interpret is 0. 1, 2, 3, 1, 2, 3.
2 plus 2 into.
Okay, tell me.
Minus 2 equals 2V.
How much?
Minus 1 meter per second.
Is the velocity of recoil of gun. Recoil of gun. Velocity of recoil of gun. Same question, one more I will tell you if anyone is interested. Same question. Because they are very, very important. That's why. Mass of bullet is 30 grams. Velocity of the bullet is 150 meters per second. Mass of gun is 2 kg. Velocity of recoil of gun is what? Anyone? Anyone, Shippy? Anyone wants to say? Hansika, you tell. Neeraj? Anyone? Rugved, you want to tell? Rugved?
Sir, this is Neeraj.
Tell.
m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2
Momentum before collision is equal to momentum after collision. Then
after
mass of bullet into initial velocity of bullet
plus mg ug is equal to mb vb plus mg vb.
a lot of disturbance. Tell me.
30 by 1000
Into 0.
into 0 plus 2 into 0 is equal to
Lot of disturbance. Tell me
30
mass
by
of.
1000 into 100 plus 2 into
Okay, meteor audio. Meteor audio. So much disturbance. So children, this is everything is 0. 1, 2, 1, 2, 52, 30, 30 by 0 is 3 plus 2 each. So children, this comes here. Minus 3 is equal to 2 each. 2 goes down. Vg is equal to minus 3 by 2. That is minus 1.5 meter per second. Is the velocity of recoil of cancer. That is how we are going to do children. So we'll do max.